Hello everyone, welcome to the very first video on the NumPy lecture series. In this video, we're going to be talking about some of the basic functionalities in NumPy library and some of its pre-built functions. So NumPy is essentially a data library in Python which is used for data manipulation. And the number one reason NumPy is so important for data science with Python is that almost all of the libraries in PyData ecosystem rely on NumPy as one of its main building blocks. And also NumPy is incredibly fast when it comes to complex mathematical calculations. So enough with the introduction, let's just get to the topic. For this lecture, I'm going to use Google Collaboratory. You can use Jupyter Notebook or any other IDEs as you wish. In order to open up Google Collaboratory, open your favorite browser and type in Google Colab. And click on the first link that appears. Open a new notebook and wait for it to load up. Once it is done, you have to go and change the name of the notebook, and I'm going to name this NumPy class 1 C1. Okay, fine. So the reason why I suggest Google Collaboratory is that it's really convenient. You don't have to install any programming languages in your computer. You just have to open up a browser and you can code and execute everything in the browser itself. You just have to have a stable internet connection for this. Okay, fine. As you can see, there are these things called cells. Google Collaboratory is very much similar to Jupyter Notebook. These things are called cells, and we can write our code and execute our code separately in each cells. You don't have to run the entire code on the screen every time you run specific thing. For example, you have to, if you want to print something like print 1, 2, 3, you just have to write the code and just press shift enter to run the cell, and the cell will be executed in a few seconds. Yeah, as you can see, 1, 2, 3 is printed, and now in the second cell I'm going to print hello world, and if we press shift enter, the second cell is executed without executing the first cell again and again. So yeah, that's about the basics of how to use Google Collaboratory. Now let's go to NumPy. So the basic data structure in NumPy is an array. There can be one-dimensional, two-dimensional, and multi-dimensional arrays. A one-dimensional array is called a vector, and a two-dimensional array is called a matrix. Now let's learn about how to make an array in NumPy. So I think you guys are familiar with I hope you guys are familiar with the basics of Python. And if not, I strongly recommend you guys go check out some videos on YouTube. There are free resources available in YouTube about the basics of Python, and go check that out and come back after you learn the basics. And in Python, in order to create a list, we just have to supply our elements inside a square bracket like 1, 2, 3, and now this is a list, and we can pass this into a variable lst, and we can print this list like print lst, and the list is printed as 1, 2, 3. Now to create an array, we have to import the NumPy library into our code so that we can access the features, and in order to do that, we have to type in import NumPy as np. You can give any name at the place of np. What I mean by this code is nothing but just np is just an object that points to the library NumPy, and we can access every functions and attributes inside NumPy using np and a dot operator. So that's about it, and now let's go and create an array. So there is a pre-built function inside the NumPy library which is known as array function, and in order to create an array, we just have to pass the elements as a list as a parameter inside the array function. In order to access the array function, we have to use np dot and write down the function name, which is array, and pass the list as the parameter, and just press shift enter. And as you can see, a one-dimensional array is created. You can also create this array without passing a variable and passing the list directly, np dot array, and pass the list directly, which is 1, 2, 3. And the array is created. And as you can see in the picture given, this is how an array is stored inside the NumPy. So this is a one-dimensional array. We can create two-dimensional arrays as well. And in order to do that, we have to pass a list of elements, just like this, np dot array. And we have to pass a list with first list containing the first row elements, which are 1, 2, 3. Second list containing the second row elements, which is 4, 5, 6. And maybe the third row containing like 7, 8, 9, and just hit shift enter. And as you can see, we have a two-dimensional array with and the way you can recognize a two-dimensional array is by checking. As you can see, there are two open brackets at the beginning and at the end of the array, and yeah, that is how we create a two-dimensional array. Now, moving on. We don't necessarily have to create an array by providing each and every elements as a list. There are actually built-in generation methods to actually create arrays a lot faster and a lot simpler. And let's check some methods that we use. In order to create an array completely filled with zeros, we can use the function called 0, np dot zeros, and pass in the number of elements that number of zeros that we want in the array. I'm passing 4, for example, and just hit shift enter, and we have a one-dimensional array with 4 zeros in it. In order to create a two-dimensional array, just have to type np.zeros, and you have to specify the rows and columns inside a tuple. Like I need 3 rows and 3 columns, and just run, and we get a 3 by 3 array with all elements as zeros. Let's do one more example. Zeros, and let's specify a tuple with the elements maybe like 4 rows and 5 columns, and just run it, and we have like 4 rows and 5 columns of everything as zeros. And if we want every element as 1, we can create it by np.ones, and just specify the number of ones that you want, and I'm specifying 4, and just run it, and I have an array with 4 elements as 1, and it is one-dimensional. And now if you want a two-dimensional matrix of all the elements as 1, just type down np.ones and specify the size of the matrix as a tuple with the rows first and columns second. Let it be 4, 5, and just run the cell, and you get 4 rows and 5 columns, everything filled with 1. Now, if you want an identity matrix with the identity matrix, you can just use the function I, which is represented as np.I, and specify the number of identity elements you want, maybe 4, and you get a 4 by 4 matrix with all the diagonal elements 1. If you don't know what's an identity matrix is essentially a square matrix with all the diagonal elements 1 and all the other elements as 0. So now let us get to know some interesting functions that can generate random numbers as well. First of all, let us generate some random numbers in a uniform distribution. In order to do that, just type in np.random.rand, and let's apply any number, maybe 4. And it shows, and it gives me 4 elements in a one-dimensional array, which is in between 0 and 1. These numbers are always in between 0 and 1 in a uniform distribution, not necessarily integers. Okay. And now if I want a two-dimensional array with random numbers between 0 and 1, I just want to type in the rows and columns without not in the form of a tuple like 4 and 5, and we get an array, a two-dimensional array with 4 rows and 5 columns with random numbers generated between 0 and 1, and these numbers are uniformly distributed. And now let's check out another interesting function, which is np.random.randn, which returns us random numbers in a normal distribution which is centered at 0. So we are getting negative numbers as well. If we type in 4, we get a one-dimensional array with 4 elements which can be negative and positive, and when we type in specify the rows and columns, we get back rows and columns with both negative and positive integers, which are all inside 0 and 1. 0, 1 and -1. Okay, fine. And now let us see how to generate a random integer rather than a decimal number. And for that, we have to just type in np.random.randint, and as the details suggest, we have first parameter is the low, the second parameter is high, and we can specify maybe I need a random integer between 1 and 10. In this, 1 is inclusive and 10 is exclusive. What that means is I will get a random integer in return from starting from 1 is included, up to 9, 10 is not included. I will get a random number between 1 and 9, 1 and 9 included. So if I run it, I'll get back 4. So what if I want multiple numbers in between 1 and 10? Maybe like 4 numbers between 1 and 10. For that, I'll have to just copy and paste this. And as the third parameter, I'm going to specify the number of numbers that I want in return, maybe like 5 numbers between 1 and 10. And I'll get back exactly that. I'm getting a one-dimensional array with 5 elements between 1 and 10. 5 integers between 1 and 10 to be precise. Okay. So there is this function in NumPy called range function, and we use it quite commonly, and let's see what arrange does. It's a range, not, you don't have to confuse it with arrange. It's np.arrange, and it takes a start index, a stop index, and a step index. Let the start index be 0 and separate by commas, and comma, let the stop index be maybe like 5, and by default the step index is 1, and I'll explain to you what everything means. Let it be 1. Okay. Now if we run it, we will get back 1, 2, 3, 4, 5. 5 integers, 5 integers between 0 and 5. So the start index is 0, and we have the first element 0, and the end index is 5, which means n minus the index minus 1th element will be given. So there will be a total of 5 elements where the start index is included and the end index is excluded. And end index minus 1 is given in the output, and the step index means we have to step to the very next element. Step index is equal to 1 means we have to step into the very next element. What if we give the end index as 11 and we give step index as 2? It will start from 0 and it will give out only even numbers. As we can see, it gives out 0, 2, 4, 6, and 8. The reason we get 10 is because we have provided 11 as the stop index, so it gives 11 minus 1th element as the end element in the array. So that's about the arrange function, and there is this another function which is very similar to arrange function, which is called a linspace. And let's see what linspace does. And in linspace, it returns equally spaced numbers between a particular range. For example, let me give, I want 10 equally spaced numbers between maybe like 1 and 5, and let's first we have to specify the start index and we have to specify the end index, and in this both start index and end index is included, and I want what I want like 10 numbers. So yeah, it gives equally spaced 10 numbers between 1 and 5. And now don't confuse this with a two-dimensional array, because you don't have 2 square brackets in the starting and at the ending of the array. So this is still a one-dimensional array. Now let's look at one more example with np.linspace. Maybe Like I want 10 numbers equally spaced between 1 and 10. So we specify the start index, stop index, and the number of elements that we need in return. And when we hit enter, we get 1 2 3 4 up to 10, which are 10 elements between 1 and 10. So enough with array creation. Let's just get familiarized with some useful functions that we use in NumPy, and one of which is the reshape method. And what reshape essentially does, it, as the name suggests, it reshapes your array. If you have a one-dimensional array, we can reshape into two-dimensional array with whatever size you want. And as an example, I will give you, let's just use an arrange method to create an array. Let's just say np.arrange maybe like I need 20 elements from 1 to 21. So maybe 1 to 21 means there will be 20 elements, and if you run it, we can see 1 to 20 elements. So let's just copy this into a variable, maybe arr. So arr is an array with 1 to 20, and let's just reshape, see what arr is. So this is arr. Now let's reshape arr into a two-dimensional array with maybe like 5 columns and 4 rows, because I have to fit 20 elements in it exactly. So arr dot reshape 5, 4. And as you can see, we have converted it into a two-dimensional array with 5 columns and 4 rows. Make sure you give the right dimensions, because if the elements can't be fixed perfectly, it will show you an error. For example, if I copy this code and paste it over here, and let's just change the size of the two-dimensional array into 5, 3, which can only fit 15 elements, and it will show you an error as cannot reshape array of size 20 into a shape of 5, 3. So make sure your shape fits exactly the total number of elements in the array. So that's it about reshape function. Now let's see a few more functions. We have a max function, min function, which gives you the maximum number, the largest number in an array. For example, let's see what's the largest number in arr dot max function, and it gives out 20. Yeah, that's correct. Let's see min function, and it gives out 1. Okay, perfect. We have other attributes as well, which is like we can know the shape of an array, like arr dot shape, and it gives out 20, 1, because arr is a one-dimensional array. Let's see, let's copy this to arr2 equal to this, and maybe like I need to know the shape of arr2. Okay, arr2.shape gives out the shape of that array, which is 5, 4. That's perfect. Notice I don't use a bracket here because this is an attribute and not a method. And I have another attribute, which is arr2.dtype, which shows the data type inside the array, and which is an integer. So that is up for today's video, guys. I'll meet you in the next video with some operations that can be done on arrays. Let's start with slicing and dicing and just move on to mathematical operations. So thanks for watching the whole video, and if you like the video, don't forget to subscribe, like, and share this video. Thank you, and have a nice day, guys. I'll see you in the next video.